First up, let's just review marking those out. So I'm going to give you a minute, mark the diagram with the congruent statement. Now remember, you might use doubles where I use singles. It's okay, as long as the parts match. And we should know distance formula. I think we know distance formula by now. Two. Elliot, you okay?
I tried to bring my folder and I found.
Sorry, I shouldn't have that. All right, so you are going to need your calculator for this distance formula problem, just for the record. I'm going to actually do these out of order. I'm going to do the least amount of work one first. Write the equation of line that passes through the point parallel to x equals 12. So first thing you have to recognize, what special type of line is x equals 12? So you guys doing this? Vertical. So if we want to make it a course parallel, we need another vertical line, aka another x equals style. Well, if we have to go through that point, x better equal what? Now, just to review, what if it said perpendicular? Y equals, and on this one, obviously, y equals 8. I love the no work problems. Okay, distance formula. I mean, a little bit of work, but I still don't think it's awful. I'm sure we all picked that one out on the matching vocab quiz, right? Now, do I care if you label the points? No, I don't care. I just like to for dramatic emphasis. x2 minus x1 squared, y2 minus y1 squared. And of course, you end up with what lovely final decimal answer? Elliot, face the front, please. What do we have for a decimal answer? 6.4. Perfect. Okay, let's do the markings. Now, again, you might have yours marked differently, but the corresponding parts would be the same. Now, I'm lame. I just go in order. So I'm like, okay, angle Q, angle Q. I'm going to do angles first. So I'm like Q and Q. So these guys. Okay, that's fine. Cool. All right, and then I've got R and R matched up. Okay, so I'm going to put the doubles here. You might have singles here, doubles there. Who cares? I mean, whatever. And then, of course, our third letters, P and H. So I'm going to put the triples there. So that's why I said you don't have to have the exact same markings I do. Just have the corresponding parts the same. Now, sides, okay? So I just look at the letters, QR and QR. Well, notice QR is that shared side. I started with this one on purpose. So I'm going to mark it's congruent to itself. Do you remember what property that is when you have the exact same thing equals the exact same thing? It starts with an R. Reflexive. We're gonna need it in the next several days just for fun, just to throw that out there. Okay, then I'm going to do, I don't know, the outside letters. QP, QH. So QP I'm going to put 2 on, QH I'm going to put 2 on. Then obviously I'm going to put 3 on the remaining side. Now, like I said, I find that tedious to have to mark out all the sides and all the angles to show the triangles are congruent. So we want to give you some shortcuts today, and well, the next several days, so to speak. So today we're going to use what's called SAS, which stands for side, angle, side. There are 5 ways, 5 shortcuts, you got to fill these in on the notes, 5 shortcuts to prove the triangles are congruent. Now, just to give you a little, clearly we're doing this first one today, what all these crazy letters mean. S stands for side. A is an angle. Now, of course, that second one, the HL, the H stands for hypotenuse. So if you think about your Pythagorean theorem or your right triangles, that's what we're talking about, hypotenuse. And then L stands for leg. So if you want to know what any of those letters stands for, of course, you do not ever have to write out like side, side, side. You can just use S, S, S. You can use the shortcuts, just for the records. Okay, so let me give you a minute to fill in all 5 of those. Like I said, we're not doing all 5 today. We're just going to focus on that top one, side, angle, side. Now, the order of these do matter, okay? Because we're going to talk a lot about here on side, angle, side, the A being in between the S's. The A is what we call an included angle, which is going to be important when we start looking at some pictures. The last thing you got to fill in is down there on the blank by the star, which I'm just off the screen here, which is this SAS one. So some shortcuts. Let's get to it. Okay, so there's nothing for you to fill in here yet. We'll do the blanks, but you do have to fill in those two blanks. But I just want to point out these included angles. So they're in between the sides. So when we start filling in the blanks here, if two sides in the included angle of one triangle are congruent to two sides in the included angle of the second, then the triangles are congruent. So you don't have to mark out all three sets of angles and all three sets of sides. This is going to be less work for you. And again, side, angle, side. The angle today has to be, because you're going to see they're going to try to trick you on some of these, the angle has to be in between the two sides. I know, I'm being very dramatic about that, but that's the key for today. So of course the last thing you got to fill in at the very bottom of your notes there, just off the screen there, is this next to your little star, what this all is for, a shortcut to show the triangles are congruent. So let me give you a minute to write that on the final blank down there. And then you can flip it. And yes, we're writing proofs again. I feel the enthusiasm, class. I do. I don't feel it. Okay, so the next page, before we actually get to the proofs, don't panic, they're not on the next page yet, as we're like working our way up to them, of course, right? Working our way up to them. So again, first thing we have to do is kind of practice the side, angle, side, and picking out which triangles have an included angle. So there's nothing for you to fill in on your notes, just take a look at this. Again, we're really hitting this included angle thing. So angle 1 is your included angle between these two blue sides. It's in between them, included, okay? So, cover the board here, I'm going to color code it. Use the diagram to name the included angle between the given pair of sides. So LM, this top blue one, and LN. So this is your included angle. Now here's the thing, to name it, this is kind of the Debbie Downer part, I can't just say angle L because L's on multiple angles here. So I'm going to use the three letters. I'm going to call it angle MLN. You could have that flipped around too. You could have angle NLM also. Okay, NO, so the bottom, red, and OL. I like this one. I can name that one easy. What's your included angle for the red sides? Angle what? Angle O, got it. We don't have to worry about the three letters. That's the only variable there on that vertex. All right, let's do purple for the next ones. ON, so the bottom again, and LN. Okay, so again, in between the purple sides would be that angle. Unfortunately, I gotta use the three letters because N is on multiple angles. I'm gonna call it angle ONL. And you could have that reversed LNO if you wanted to. And last but not least, MN and NL. Okay, you name it. What's the included angle between the green? Angle what? MNL, got it. So any questions, I know, very dramatic about this included angle, but that's the key for today. Any questions on how to identify that? Okay, let's look at the next round triangles here. Now, determine if side, angle, side could be used to prove each pair of triangles congruent. Here's the deal. Two answers are yes, two are no. Can you figure out which is which? Two yeses, two nos. All right, what do you think about one, yes or no? Yes, because we have side, angle, side on both triangles. Side, angle, side. Okay? What do you think about, I'm going out of order just because I'm standing here. What do you think about 3? No. Are there even any sides marked congruent on this guy? No, angle, angle, angle isn't a thing. Okay? So which one out of these then is the yes? 2 or 4? 4 is the yes. Because what lovely angles are these guys? Vertical angles. Okay, remember we're writing proofs today. Vertical angle congruency theorem is still in play. Side angle side. Got it. Now, let's just talk about why is 2 a big fat no. Because I look at and I'm like, well, this one's side angle side. Wait a minute. She lied to us. Is this your included angle? No, that is the glitch on that one. It would have to be this bottom right corner angle with a congruency mark. That is not in between the 2 sides. That is what is ruining it. Just for the record. All right, flip it. Let's write some proofs. Are you ready? Okay, I feel the enthusiasm. All right. Ooh, good vocab word there, midpoint. Z is the midpoint. Forgive my sloppy handwriting here. I have XQ and PY. Got it. So we use that to write your given in. Now, of course, the key vocab word in the given is what? Midpoint. It was just on your vocab quiz. That's what I gave it today. What's a midpoint do? Cuts it in half. So I'm going to mark that up on the picture first. So it says Z is the midpoint of XQ. So these 2 sides are congruent. Cuts that guy in half. It also says Z is the midpoint of PY. So these halves are congruent. Now I always mark on the picture first. Clearly we're using side angle side, no mystery here. We have our angles in the middle congruent because they're what type of angles? All right, so all I have to do is get all of that written out in the proof. I'm going to start with the green first. XZ is congruent to ZQ. Segment XZ is congruent to segment ZQ. Now, why did I mark those congruent? What made me mark those congruent? What in the given? Midpoint. Now, isn't that the same reason I marked the red ones? So you don't have to do those in separate statements because it's midpoint for both of them. I'm going to put the red ones on here also. So YZ is congruent to ZP. And that was the same reason for both of them because they gave me that midpoint. So definition of midpoint. Okay, let's do the purple angles. And again, why did we mark those angles congruent? Yeah, vertical angle congruency theorem, so a little backed. Now, of course, you know what? Sadie, I'm going to have you move up here since I can constantly hear you guys chattering. I don't want you to be distracted during your proofs. Come on up, sister. Okay, vertical angles, of course. I can't just say angle Z is angle Z. I'm going to have to use the 3 letters. I'm going to call angle XZY. And then I'm going to call the other one PZQ. But you know what? I think we're almost done. Because look at, first off, look at the pictures. Do we have side angle side marked in the picture? Sure do. Do I have side angle side in my actual proof? I sure do. Into the proof line, side angle side. So that is the one, I know you guys don't like proofs, I'm going to try to sell it a little bit. Nice thing about this chapter, you have this very specific side angle side reason to use. And eventually we'll use those other ones, side, 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 angle, angle, side. Some of the other ones, but just side, angle, side for today. So any questions on this guy? All right, let's do the next one. So, of course, do your statements, reasons, let's fill in the given, all the stuff, you know. BC, congruent to DA, BC, parallel, AD. Now, as soon as I saw that parallel symbol, which remember, mine are red, those little red triangles, I was like, oh man, I'm already thinking alternate exterior, alternate interior, corresponding, all the stuff from chapter 3. Clearly, we know we're using side angle side. First thing I'm going to do is try to figure it out in the picture. Well, they already gave you the side. I like they have a common side, so I'm going to mark this shared side in the middle. So there's my second set of sides, and then of course, I'm going to mark these angles congruent, and I'm going to thanks Ben, I'm going to mark these angles congruent, and we're going to talk about the why. Why are those green angles congruent? What special name do they have? Alternate interior. So I'm looking at my triangles. Side, angle, side. Side, angle, side. We've got it all. We just have to write it out. So the first thing I did is, and it doesn't matter what order you put the pieces in your proof, we just need all of them. I did the purple markings first, so I'm going to list that first. So I've got that purple marking, that shared side. I'm going to say AC is congruent to AC. Now, we haven't used this in a while. It's been a hot minute. What property is that when it's the same thing and the same thing? Reflexive. And you will start seeing that more and more this chapter, just to warn you. All right, the next thing I marked then were the green angles. Now, I can't just say angle A and angle C. I'm going to have to use the 3 letters. Okay, here we go. I'm going to call it angle DAC. And I'm going to call the top one, let's go BCA. I can't remember who said it, but they pointed out to us we had alternate interior angles. Interior. Got it. All right, let's take a look at what we have in our proof. I've got a side, I've got my green angles, I got my purple side, I got it all in here, we're done. My proof line. Side, angle, side. That's not so bad for a proof. We've done worse, I think. Maybe. All right, when you're done, of course, flip the page. We got one last thing to talk about, and a little SAT practice problem. Why not? Ready? So one thing I just always get asked about over all those, 5 shortcuts, I always have somebody is angle side a thing. I was like, well, that's fun. Side angle, not a thing. Side angle, side. Just to show you, you can draw 2 different sizes of triangles with side angle. Like here I have an obtuse one. Here you have, almost looks right, probably acute, but side angle is not a thing. I always have somebody that gets creative this chapter and wants to put side angle or angle side. We'll just leave it there. Okay. Figure not drawn to scale in the figure r is parallel to t. What's the value of x plus y? All right. So my advice, because you have angles with x in them, angles with y in them. Start with the ones that have x. Let's look at these first. Now, we should know it from last chapter. What special type of angles are those? Consecutive, interior. So are they equal or do they add to 180? 180, so I'm going to total them up to 180. A little math to do here. We got it. So of course I'm going to combine my x's, 5x, 3x, let's make it 8x. And I'm going to go ahead and subtract the 4 off. Punch that in. X equals what? 22. Now we're also going to need y. Now you have some options here to get y. These 2 angles, of course, make your linear pair. I'm kind of sick of 180 though. There's also a relationship with this guy, which I think might be easier. They're alternate interior. So if I put my 22 in here for x, 3 times 22 I know is 66. And I know alternate interior angles are congruent. So I'm going to do 5y minus 9 equals 66. So let's add the 9. And let's divide the 5. What's 75 divided by 5? Okay, now notice 15, 22 aren't even in the choices. Because that didn't mean we didn't run, they just get fancy. They want, for a final answer, what is x plus y? 37. Got it. See, that wasn't so bad, just kind of worried. Any questions about that one? All right, so, all right, good news, bad news. You ready? What do you want first? Bad news is there's 4 proofs on the homework. Good news is it's only a front and a back.